Topic is on rotations. Our essential question is, what effect does a rotation have upon a shape? Here are your vocabulary words. Pause the video so you can study these vocabulary words because we will be using them during the lesson. Here's a problem. It's similar to the ones we have done in the past for our lunch. Your friend nearly completes his figure. He traces a square, turns it, traces it on one side, then curiously quits. Complete the turn and the tracing of the square. Explain why your tracing shows your friend's turn. As you can see here, this point here is the point of rotation. That's the point that does not move. Everything else rotates. So, to complete this square, we will rotate it twice, once here in this area, then turn it again to fit in this area. Okay. It says here that with the original square was turned around the dot so that the left side of the original square became the right side of the traced square. My friend could turn the square clockwise or counterclockwise. Doesn't matter what direction you go. How my tracing shows the turn. All the sides I trace reflect the same turn of the square around the dot. Remember, the dot is the center of rotation. It will never, ever move. Your figure will move around it. To find an angle of rotation, we're going to draw a straight line from the original point to the center of rotation. In this case, the center of rotation is the point of origin, 0, 0. So all we have to do is draw a straight line from our original point A to 0, 0. Let me change colors so you can see that better. Then we're going to draw a straight line from the point of origin to A prime. Then we're going to measure the angle formed. So you could click on this protractor here, put it on the point there, and then we're going to rotate it. And let's move it some more. As you can see, we're pretty close to 90 degrees. So all you have to do is draw a line from the original to the point of origin, and then from the point of origin to the prime. And it doesn't matter which point you use. We could have used point B as well. Pick a different color. Could have gone from point B to the point of origin, and then from there to B prime. And again, it makes a 90-degree angle. Triangle ABC maps to its image, triangle A prime, B prime, C prime, so that A equals A prime, B equals B prime, and C equals C prime. What is the angle of rotation? It doesn't give us any specific points, so we can draw our own wherever we want to. So I'm going to call this point A, this B, and this one C. They tell us in the word problem that A equals A prime, B equals B prime, and C equals C prime. So that means that the very same points are used for our image as well. But they also tell us that our problem, our shape, did rotate, so it had to move. Okay? So we need to think of a rotation. How many degrees would a shape rotate around the point of origin and wind up in the exact same spot? Well, if you look at the coordinate grid, you wind up in the exact same spot, just like a wheel, with every 90 degrees. So it's 90, 180, 270, 360. We have made a complete circle, and circles are 90 degrees. It can also rotate any multiple of 360. So if we want to go around the grid twice, one circle, two circles, that would be 720. We go around 3 times, that's 1080, and so on. There are many types of rotations, usually in the form of 90 degrees. So 90, 180, 270, and 360 are the ones that we're going to focus on. Right now we're going to work on 270 degrees around the point of origin. Here we have triangle ABC, and it will rotate 270 degrees to triangle A prime, B prime, C prime. And we have already learned about arrow notation, but what I want to point out specifically is the points. A is at negative 4, 6. When you rotate it 270 degrees, it becomes A prime at 6, 4. B is at negative 2, 1. B prime is at 1, 2. C is at negative 1, 4. C prime is at 4, 1. Can you tell what has happened? As you can see, whenever we make a rotation of 270 degrees, points X and Y switch places. So Y becomes the X coordinate, X becomes the Y coordinate. In addition, the X coordinate changes signs. So if X was positive, it becomes negative, such as in point B. And point C, where X is negative, it becomes positive. Point P has coordinates 3, 0. If you rotate P 270 degrees about the origin, what are the coordinates of P prime? Remember the rule that we discovered earlier. We will take our X and our Y and they will switch places. So if our point is at 3, 0, that means they will switch places, and our x that was positive would become negative. So our new point is at 0, -3. So the correct answer is D. Now I want us to look at some other common degrees. Okay, we already talked about 270. XY becomes y negative x. 90 degrees is very similar to 270. Once again, x and y are going to switch places, but this time it's the y that changes signs. So whatever sign y was, if it was positive, it becomes negative. If it's negative, it becomes positive. Now, to help you remember what 180 is, remember when someone says someone has done a 180, basically all it means is they have changed direction. So left becomes right, right becomes left. Okay? When it comes to number lines, it's positive or it's negative. If you do a 180, negative becomes positive. So the numbers stay in the same place, but they switch signs. So what once was negative now is positive. So for example, if we had the point 5, -4, it would become -5, +4. You definitely want to memorize these rules about rotating by 90 degrees around the point of origin. It will make everything so much smoother, especially when it comes to graphing your new points. If you can answer these questions, then you know you're good to go with the homework for tonight. What effect does a turn have on a figure? Well, we have already said, as with the other transformations we have done, reflection and translations, a rotation will not have that much effect as far as the size and shape of a figure, but what it will affect is the position of the figure. Okay? Alright. Using arrow notation, we will show how triangle JKL maps to its image after rotation 180 degrees about the point of origin. So remember, with the 180 degree rotation, it will stay the same as far as x and y. So J is at 1, -1. So x will still stay x and y will stay y, but they will switch signs. It becomes -1, +1. K is at 4, 1. So K prime would be at -4, -1. And L is at 3, -3. So L prime should be at -3, +3. And just to make sure we got this correct, we are going to graph this. So we said J prime will be at -1, 1. K will be at -4, -1, K prime. And L prime will be at -3, +3. Okay, let's connect. And that is looking pretty good. Okay, the vertices of parallelogram WXYZ are W is at -1, 1, X is at 3, 2, Y is at 3, -1, and Z is at -1, -2. The vertices of its image parallelogram W prime, X prime, Y prime, Z prime are W prime is at -1, 1, X prime is at 3, 2, Y prime is at 3, -1, and Z prime is at -1, -2. What's the angle of rotation? Well, as we look at these series of points from the original to the primes, we see that the numbers have not changed. They're the exact same numbers. The only way that could happen is if we rotate it all the way around the coordinate grid. Rotation all the way around is 360 degrees. Alright, how are reflections and rotations the same, and how are they different? Remember, all the transformations we have studied so far change the orientation of the figure, okay? They either slide them, flip them, or rotate them, but they do not change the size or shape, okay? The difference, though, is that reflections flip the figure across a given line, while rotations turn the figure around a given point. Okay, think of it this way. A mirror image flips while a rotation turns. Okay, let's look at this next one. Will the relationship between the vertices of any figure rotate 360 degrees and its image always be true, regardless of the point of rotation? Explain. Well, remember, think of a wheel. A wheel is 360 degrees. And when you turn a wheel 360 degrees, you go right back to its beginning. So, it does not matter if the point of rotation is inside, outside, or on the figure. The figure and its image will always be the same. Again, think of a wheel. This problem asks which of these graphs shows a rotation. We're going to do one better. We're going to actually tell what each of these are. Okay? Graph 1 is a translation, or what we call a slide. Graph 2 is a reflection, also known as a flip. Graph 3 is a rotation. And more specifically is a rotation of 180 degrees. We also call that a turn. So it is graph C. Again, they're asking which of these shows a rotation about the origin. Again, we're going to do one better. We're going to tell what each of these are. This one's a reflection, specifically over the x-axis. This next one is also a reflection. But this time it's over the y-axis. And C is a rotation of 90 degrees. Again, reflect, we flip. In B, we also flip, but we went over the y. Rotation, 90 degrees. And again, look at your points. Q is at 9, 8. So the new Q would be at -8, 9. Because again, X and Y are going to switch unless it's 180. Okay, this one asks how many degrees or what is the angle of rotation about the point of origin that maps triangle PQR to triangle P prime Q prime R prime. But as you can see, all it did was rotate it counterclockwise 90 degrees. So the only answer that says 90 degrees is answer C. Okay? Alright, so they want to rotate triangle XYZ 270 degrees about the point of origin. We have to remember that whenever we are rotating 270 degrees, we can follow the simple rule of XY becomes Y negative X. So again, all we're going to do is switch the position of our coordinates and change the sign of the X. So for example, X is at -2, 2. When we switch places, it becomes 2, -2, but remember the X has to change signs. So we're going to make that -2 into a +2. Same thing for Y. We switch places. So -5, 3 becomes 3, -5. But again, the old X loses its sign. So negative becomes positive. And for Z, 5, -2, but again, the 2 has to lose its sign. Change sign, so negative becomes positive. So now we have our new coordinates. Now we're going to graph these coordinates just to make sure that we are right. So X becomes 2, 2. Y becomes 3, 5. And Z becomes 5, 2. And then we draw our lines. And that looks perfect. Point N has coordinates 7, 1. If you rotate N 90 degrees about the origin 0, 0, what are the coordinates of N prime? Again, 90 degrees. If you will recall, 90-degree rotation means we're going to take our X and our Y, switch places, but this time it's the Y that changes its sign. So if we are already at 7, 1, that means we're going to change it to 1, 7, but give the 1, change the 1 sign. So it's positive, so it becomes negative. So our point is at negative 1, 7. Which if you were to rotate it 90 degrees, let me get out my let me make a straight line from N to the point of origin, and then from my point here to the point of origin, as you can see, it's a 90-degree angle. So again, we know we're right. Point M has coordinates 1, 7. On a quiz yesterday, Janet incorrectly claimed that if you rotate M 270 degrees about the origin 0, 0, the coordinates of M prime are negative 1, negative 7. Find the coordinates of M prime. What was Janet's likely error? Remember, 270 degrees is almost a complete circle. Not quite. So some things are going to move around. Again, we start with X and Y. Remember, they switch, and X is going to change its sign. So, if the coordinates were 1, 7, that means the new one should be at 7, negative 1. It looks like what Janet found was the coordinates if you have 180-degree rotation, not 270. So she only rotated it 180 degrees. And that is what her error was. An architect is designing a new windmill with 4 sails. In his sketch, the sail's center of rotation is origin 0, 0, and the tip of one of the sails, point W, has coordinates of 7, negative 6. He wants to make another sketch that shows the windmill after the sails have rotated 180 degrees about the center of rotation. What would be the coordinates of W prime? Alright, let's us first graph the original. The original was at 7, -6. So 1, 2, 3, 4, 5, 6, 7, and -6. 6 down. 1, 2, 3, 4, 5, 6. So this is our original point W. We want W prime, 180 degrees. That's the important part. Okay? So we have 180 degrees. That means that if you remember your rule, 180 degrees meant that X and Y stayed in the same place, but they changed signs. Okay? So if it's 7, -6, that means now that the new point is at -7, +6. Right here. Suppose triangle TRI is rotated 180 degrees about the origin, 0, 0. In which quadrant is triangle T prime, R prime, I prime located? Make a graph showing triangle TRI and triangle T prime, R prime, I prime. Okay, first step. It told us we need to rotate 180 degrees. Okay, remember 180 degrees. Think of about face. Okay, the only thing that's going to change is the signs. So we look at T. T is at 5, 2. That means 180 degrees at T prime would be -5, -2. R is at 7, 6. That means R prime would be, sorry about the interruption, R prime is at -7, -6. And I is at 5, 5, which will make I prime at -5, -5. When we plot these points, we will see our rotation. So T prime, R prime, and I prime. Again, Just plot the points. Remember your rules. As we look, we can see that T prime, R prime, and I prime is in quadrant 3. Find 3 angles of the rotation about the point of origin 0, 0 that map W, X, Y, Z to W prime, X prime, Y prime, Z prime. Use paper and pencil. Does a negative angle of rotation make sense? If so, find 3 negative angles of rotation about the point of origin that map W, X, Y, Z to W prime, X prime, Y prime, Z prime. If not, explain why not. First step, let's decipher this word problem. We need to find 3 angles of rotation that will lead us from the original to our image. Okay? Just looking at this. Okay, we see W is at 3, 3. W prime is at -3, -3. Just from that point alone, we know we're at 180-degree rotation, because the numbers have not changed places, just the signs. So we already know that we're at 180. Now we need to find 3 more angles that will put us right back at this spot where the image is at. Again, remember, to get back to this spot, we have to rotate 360 degrees, a wheel. So if we already rotated 180 to get right back to the same spot, we need to add 360. 360 plus 180 is 540. And from 540, we can add another 360, and that will give us 900 degrees. So we can mark that too. Any questions? Now, does a negative angle rotation make sense? So far, we've been dealing with counterclockwise. We've been turning everything to the left. Okay? If we turn everything to the right, what will we call it? Well, the opposite of counterclockwise is clockwise. But there is such a thing as negative rotations too. Positive counterclockwise, negative clockwise. Rotate rectangle PQRS 90 degrees about the origin 0, 0 to get rectangle P prime, Q prime, R prime, S prime. Then rotate rectangle P prime, Q prime, R prime, S prime 90 degrees about the origin 0, 0 to get rectangle P double prime, Q double prime, R double prime, S double prime. What transformation can you perform on rectangle PQRS to get rectangle P double prime, Q double prime, R double prime, S double prime? First step, deciphering this word problem. Okay, First, they want us to rotate, okay? And we need to rotate it 90 degrees, about the point of origin. Okay? And we're going to call our new rectangle P prime, Q prime, R prime, S prime. So that's our first step. Okay? So we're going to take our plots, our points, and rotate them 90 degrees. Now, if you remember 90 degrees, we always took our original switched them around, but it was Y that changed signs. So R it looks like they're counting by twos. 2, 4, 6, 8. Excuse me. So R is at 7, 2, 4, 7, 6. So I'm just going to type that over here. R is at 7, 6. That means our new R would be at negative 6, 7. Negative 6, 7, which will be right here. S is at 3, 6. That's our point for S, 3, 6. That means our new S would be at negative 6, 3. Okay, we look at P. P is at 3, 4. That means our new P is at negative 4, 3. And since this is a rectangle, we know all rectangles have equal sides. And their sides are opposite and parallel. So we could go ahead and put in Q. Just make sure I have everything straight. Go ahead and draw this in. Alright. So now it tells us to rotate our image another 90 degrees. and get P double prime Q double prime R double prime S double prime. What is the transformation we have made? Okay, well, another 90 degrees. Again, we're just going to switch places. Our X and Y and change the sign of the Y. So the new R is at negative 6, 7. That means it's going to be at negative 7. Is at negative 6. 7. Switch her around again. That'll be at negative 7, negative 6. So that's our R double prime. Now if you look at the point, the coordinates, the original was at 7, 6. And the double prime is at negative 7, negative 6. Which means all we have really done is form a 180 degree rotation. You now have enough information to complete Lesson 9-3 homework. Remember, you can use these notes, the notes from your digits program, or the help such as show me how to do this problem or show me an example. Also, I have reopened assignments from lessons 6-1 through 6-7, the lessons about systems. They are reopened. They will be closed again on February 28th, 9 a.m. So make sure if you have any makeup assignments you need to do, get them done before Friday.